Ladies and gentlemen, welcome to day 19 of April's daily LeetCode challenge. Today we have question 200, number of islands. Given a m times n 2D binary grid, which represents a map of ones and zeros, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay, so the algorithm is pretty simple. We iterate through the input grid top to bottom, left to right, and we call DFS on any ones that we encounter. DFS will change all ones to hashtags and spread to its neighbors. Every time we call DFS initially on in a cell, we add 1 to our answer. And the runtime of this algorithm will be O of n, because we do have to iterate through every cell in the input array or the input grid, and the space will be O of 1. We don't use any additional space to solve this problem. And I just want to go a little more in depth on this algorithm. So if we take a look at example 1, right? First, we will iterate through the grid top to bottom, left to right. So we're going to start here on this 1. And when we encounter a 1, we will call DFS on this cell and we will add 1 to our answer. And DFS will change this 1 to a hashtag and then spread itself to its adjacent neighbors. So it will call DFS on this cell and the out of bounds cells. And the out of bounds cells will just return to nothing because they are out of bounds, and the surrounding 1 cells will be changed to hashtags as well because they are 1 cells. And then those neighbor cells will call DFS on their neighbor cells, and their neighbor cells will change itself to hashtags, etc., and it will keep going until there are no more neighbors that are ones. And the reason why we do this is so the DFS function can completely cover the entire island, so we don't count the same island twice. So with that out of the way, let's code our solution. So let's define the row and column variables, which is the length of grid and the length of grid of 0 and 4x in range rows and 4y in range columns. We'll call if grid xy is equal to a 1, we will call DFS on xy, and we will add 1 to our answer. So our answer will start off as 0, and when we encounter a land cell, we will add 1 to our answer, meaning we've found an island, and we'll call DFS to clear that island. And then at the end, we'll return our answer, and then all we have to do now is to define our DFS function, which takes an x and y chord, and let's just do some checks. So we're gonna check if it's out of bounds, and that's just if x is less than 0 or y is less than 0, or x is greater than equal to row, or y is greater than equal to column. Then if that's the case, we'll just return to nothing. And our DFS function is only used to clear land cells. So if grid xy is not equal to a land cell, then we have nothing to do here. We'll just return to nothing. And at this point in the code, we can guarantee that our XY coords are not out of bounds and we are on a land cell. So the next step is to change the cell into a hashtag and then call DFS on its neighbors. So let's define the neighbors. So the neighbors is to the right and to the left and up and down. Oops. Like that. And then for NX, NY, neighbor X, neighbor Y, in neighbors, we'll call DFS on X plus NX, Y plus NY. And I think that is the solution. We'll run the code and it works, and then we're going to submit. And our solution is accepted. Thank you for watching. See you in the next one. Peace out.